Welcome to the session number 13 from the playlist of current electricity, and the topic for the today's session is the Joule heating effect. So before proceeding further, let us revise what the Joule heating effect is. So whenever the current passes through a conductor for some period of time, then that particular conductor gets hot and it starts glowing. So this heating effect of the current is called the Joule heating effect, and the heat produced is given by this formula, that is Q is equal to I square R into T, where I is the current which is flowing through the conductor, R is the resistance of it, and T is a time of flow of the current. And this equation can also be written as V square by R into T, because we know that V is equal to IR. So by substituting the value of I equal to V divided by R, we will get the heat produced in the conductor due to the flow of the current equal to V square upon R into T. So these are the two important formulas with respect to this topic, that is Joule heating effect. Now in the question, a student has got two wires. One is of iron and the other one is of copper. Now both these two wires have got equal length and diameter. So he first joins the two wires in series and passes an electric current through the combination for some time. After that, he joins the wire in parallel and passes the current through the combination for some time. So we have to find which wire will glow first in each case. So let us first of all here, I'm just drawing here one circuit. Let us say this is a iron wire and let us say this is a copper wire. Okay? And these two wires are now connected across a voltage source like this. So a current, say I, will flow across both these two wires, and let us say this is the iron wire, this one I, this is the iron wire and this is the copper wire. Now here the length and the diameter of both these two wires are the same, or we can say that the cross sectional area of the copper wire and that of the iron is the same. Now we have to first of all find that which wire will glow first in the series combination, and then we will find that that which wire will be glowing first in the parallel combination. So in the series combination, the current will be the same in both these two wires. Now Q is equal to I square RT, where R is the resistance of the wire, T is the time of flow of current, and I is the current which is flowing through these two wires. Now in the series combination, the value of I, that is the current which is flowing through iron and the copper wire, will remain the same, and T will also remain the same. So Q, that is the heat produced, will be directly proportional to the resistance of the wire. Now here in this question, the resistivity of iron is more than the resistivity of the copper. So we also know that R is equal to rho L upon A. Now since here the length of the wire and the area of cross section of the this iron and the copper wire are the same, therefore the resistance of the wire is directly proportional to the resistivity of this iron and the copper wire. So since the resistivity of the iron wire is more than the resistivity of the copper wire, so we can say that the resistance of the iron wire is more than the resistance of the copper wire. And because of that, the heat produced in the iron wire will be more in the series combination, and because of that, the iron wire will glow first. So in the series combination, the iron wire will glow first. Now let us come to the parallel combination. Now in the parallel combination, let us say this is a copper wire and this is a, say this is an iron wire, and both these two wires are now connected in parallel across this voltage source. This is the voltage source. Let us say this is a copper wire and this is an iron wire. Now in the parallel combination, the voltage, or you can say the potential difference across these two wires will remain the same. So in this case I will be using this equation, that is Q is equal to V square upon R into T. Now since the potential difference across this copper wire and the iron wire will remain the same, therefore we can say that Q is directly proportional to 1 by R, or we can say that Q is inversely proportional to the resistance of this copper and the iron wire. So it implies that the wire whose resistance is, whose R value, the value of the resistance is less, whose R value is less, will get more hot. Means the wire whose resistance value is less will get more hot, and because of that it will glow first. So in this case, as we know that the resistivity of the iron is more than the this resistivity of the copper, so we can say that the resistance of iron is more than the resistance of copper. And now in this case, in the parallel combination, since the heat produced is inversely proportional to the resistance, so we can say that the heat produced in the copper will be more because its resistance is less than that of the iron wire. So in the parallel combination, the heat produced in the copper wire will be more because its resistance is less than that of the iron wire, and this is for the parallel combination. So in the parallel combination, the copper wire will glow first, and in the series combination the iron wire will glow first. So I hope you must all have understood the solution of this question, and in the next session I will be coming up with a different topic from the same chapter, that is current electricity. So till then, have a nice day. Bye.